So let's dive in. If you go to our website, autonomy.computer, and scroll down, over here there's an example prompt. And let's copy this example prompt. And I'm going to run this prompt in my coding agent. And you can use any coding agent from Cursor to Klein to Codex to Claude Code, whatever you prefer. In my case, I'm going to use the Z editor. So over here, I have Z. It has a coding agent. I'm going to paste my prompt in here. The developer experience looks like the following. You take this prompt, you edit it to whatever your needs are, whatever you're building, and then you take that prompt and give it to your favorite coding agent. And in about 10 minutes or so, you get a live deployed in production, ready to use by customers application. And it's multi-tenant and can be used by lots of users. And then you can tune it from there. So you get a prototype or first version live in about 10 to 20 minutes. And that's, I think, a unique experience. This particular example, I asked my coding agent to use the Autonomy documentation and build a translation application. This translation application can translate documents from English to other languages and then back to English and do comparisons of whether the original version and the translated version has changed in meaning in any way. In this particular case, I built an invoice reconciliation application. And this reconciliation application, you give it some invoice data of invoices over a month, let's say several thousand invoices. In this example, I'm giving it 3,000 invoices. And then you give it some bank transactions, like 4,000 bank transactions, and it will use AI agents to, in parallel, process each invoice and look for whether or not it has been paid or not. So it will run the 3,000 parallel agents to do invoice reconciliation. You can also do other things like build voice agents. We haven't launched this functionality yet, but it's coming very soon. But in this particular case, I built a AI voice-based interview agent. So for example, if I click here, hello, my name is Mrinal.
Hi, Ronaldo. Let's dive right in. Can you tell me about a recent project where you had to solve a complex problem? How did you approach it?
Well, like humans, it got my name wrong a little bit, but it did the job. So Autonomy takes care of all the underlying infrastructure required to build something complex like this, especially when you're building it for many users, not just for one person, not just writing a personal use script, right? So if you're building a multi-tenant product, you have to build a whole bunch of infrastructure that goes into building and serving this application, which is streaming audio from many agents and managing conversations for many users. And in this particular case, I didn't have to build any of that. All of it, all I had to do was give my coding agent a prompt with a reference to the Autonomy documentation. And what I got back was a live agent that I can talk to with multiple users, and it's live on a production-ready user URL ready for me to give to my users. So this capability is really unique to how Autonomy builds and deploys applications and how we've taught coding agents how to leverage this functionality. So I'm going to give it my prompt, and let's talk about what the prompt is saying. So the prompt is saying, hey, refer the Autonomy documentation, create a new Autonomy app that news editors can use for fact-checking news stories. The workflow is the editor pastes an article into a text box. An agent then breaks down that article into a set of claims, and each claim is then assigned to a parallel fact-checking agent. And fact-checking agents then research the claim on the internet using the Brave Search MCP server. And all the research is then given to a report-generating agent that then creates a final fact-check report. Also, could you create a nice web UI for this app using Next.js and ChatCN? deploy and test the app in Autonomy, and before you dive in, give me a README with an architecture diagram. So that's what I'm asking it to do, and it's already gotten to work. It started to reference the Autonomy documentation, and it's starting to create our architecture diagram. And so when we tell the coding agent, hey, refer the Autonomy documentation, it learns how to write code in the Autonomy Python framework. It also learns how to package that code into a deployable application using the Autonomy command line and deploy it into our cloud runtime, the Autonomy computer. Not only that, it learns that if it uses Autonomy, it can deploy additional tools next to your agent. So it can deploy an MCP server, in this case, the Brave Search MCP server, and how it needs to provide secrets. Like all of that, like complicated infrastructure capabilities are learned if you take this approach. And then a really important thing is, while all of this happens, it's not a black box. You get all the code. So all the code that it's generating is being created here. So you can then adapt it, reference it, change it using coding agents further by keeping the Autonomy documentation in context. So it's a really new approach compared to everything else that is available for developers today to ship reliable, scalable, production-ready agentic applications really, really quickly and iterate on them really, really quickly. Okay, so now we'll let the agent build, and at key points in the agent, as it goes through stuff, I'll talk you about what's going on. So far, it's created the Autonomy YAML file, which describes what containers to deploy into the Autonomy computer. And here it knows that it has to deploy the main computer, but it also has to deploy a Brave Search MCP server. And it's figured out that this MCP server requires a secret. And so it's created a secret file where it will ask me to deploy, put in my Brave Search API key eventually. And then over here, you notice that it's written it's using the Autonomy framework for defining agents, and it's built a Python-based application to write these fact-checking agents. And over here, you notice that it's creating a claim extractor agent. It's given its instructions using the managed models provided in Autonomy like Claude Sonnet, and so forth. Over here, it's built a report generator agent. And this is the claim checking agent. It even figures out how to distribute that work. So lots of parallel agents. So here, right? Create a fact checking agent for each claim. So it's able to distribute the work to many parallel fact checking agents. In the meantime, while our coding agent is at work, we can look at this other example. So Autonomy is unique because each agent in Autonomy is modeled as an actor. We wrote a Rust-based actor runtime for running parallel agents, and we used Occam as a way to create encrypted channels across multiple nodes of Autonomy. So what that unlocks is you can run distributed fleets of agents that can do complex distributed algorithms like distributed mapper use and scale horizontally very, very easily. So in this example, I'm showing the backend view of what happens if I want to analyze 5,000 PDF documents in parallel using a multi-step agentic process. If I was doing this in sequence or on a single machine, it would take a lot of time to process 5,000 documents using LLMs. But here you'll notice that I'm able to use these agents in a parallel fleet. And so if I click this run button, it's going to spin up thousands of parallel agents, each working on a single document and analyzing it and extracting some data from it. And so you'll see these little dots that each of them are an agent, and note how quickly they spin up and do their work and then spin back down, and the final results are collected. So many agents have spun up, many have already finished their work, and just a few seconds later, all the agents are done and the work is entirely done in a distributed way. So 5,000 documents were analyzed so quickly with just a for loop. The developer just wrote a very simple for loop and it just worked from there. So let's go back to our coding agent. Okay, so our coding agent has finished doing the work, but so far it's not deployed anything. It's just populated these configuration files and specifically told me to put in my API key in secrets YAML. So then it says, okay, sign up for an Autonomy account, configure your Brave secrets file, Brave key, which I've already done, and then you can run it. So let's now, since I've put in the secret, let's say deploy and test it. Now it's even running tests against our fact-checking API. And so now it sees that the API is working, the agents are responding, Brave search is working, and facts are being checked. But it found a small error, and so it's going to try and fix that and redeploy. Okay, so it sees that it's getting streaming responses from the API. And that's what another thing Autonomy does is it automatically takes care of creating streaming APIs for your agents. And it has finally opened our working app in a browser. So let's try it. It's extracting claims. It broke them down into 8 extracted claims. And now it's checking these claims in parallel. Okay, our fact check is complete. And down here, it's created results. In particular case, it wasn't able to verify stuff. In this case, it was able to verify that Jerome Powell was Fed chair at that time frame. It even found references to sources. In some cases, it was falsified the claims of like decreasing things. And then down here, it created a markdown comprehensive report. So as you can see, with very little effort, a developer is able to bootstrap a production-ready application. And this is all really good quality code. And all of this is using the external Brave Search MCP server, which was automatically hosted and run for us next to our agents by Autonomy. And then there's a whole bunch of documentation down here around various architectural decisions. Down here, it even has commands for how to then deploy this. So even the coding agent did the work, a developer can easily come back to this section and reference how to then take this application further, continue to build it using a coding agent or manually improve it. And the code that got generated here is fairly simple to understand Python, right? It's really straightforward. And so anybody can pick up from there, and there wasn't even a lot of code, but we were able to create these parallel fleets. So to summarize, Autonomy makes it really easy to create scalable, multi-tenant, secure, production-ready, autonomous AI applications. I hope you would give it a try. Check us out on autonomy.computer.